warahmatullahi wabarakatuh. First of all, thank you for the opportunity for me to present our research with the title is in silico study of the methyl sulfanyl thiazole as anti-cancer candidate. And our team is Ritsa Marjoningrum, Tita Novianti, Siswandono, Yunia Sarwatinisi, and Prof. Ari Yanwar. This research supported by Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi in 2021 in postdoctoral grant. The introduction of the research is cancer is one of the diseases with a high mortality rate caused by the growth of abnormal body tissue cells. Cancer disease whose increasing number has prompted the development of anti-cancer. And the sirtuin-1 is a NAD-dependent histone deacetylase. Is a member of the sirtuin-2 family, one of the 7 sirtuins in a human. And the sirtuin-1 is one of the target therapy in cancer therapy. So as we know, it is known that the thiaura derivatives have some activities. The sample is a nervous system, antimicrobials, and anti-tumor and anti-inflammatory. So to accelerate the process of drug discovery and development, predication of the chemical properties of the compound, pharmacokinetic properties, toxicity, and knowing the picture of drug interaction is carried out with receptor in silico. So based on the background above, it will be develop anti-cancer drug through molecular modification thiourea to see the interaction of the compound to cancer cell receptor by means of cancer cell. It inhibits the work of the enzyme sirtuin-1. This is the structure of our design compound, and this is the comparison compound. And some of the step procedure of my research is the instrument we use. The tool used in this study include hardware in the form of the computer with Intel Core i5 and GPU NVIDIA GeForce GTX and RAM 8 GB and DDR4. And the application in use is Chamber Ultra 8.0, Morphine Sketch, Molecular Viewer, via Discovery Studio, and PDP server website, and PKGSM online tool for ArtMap prediction. And step by step of the experiment is the first ligand and receptor preparation. We use the Morphine Sketch and Molecular Viewer software. And then the second, docking validation. We use AutoDock software, and then we done the docking of our compound design, and then we continue by visualization of the docking result. We use via Discovery Studio, and the last we done the pharmacokinetic prediction by the web server of the PKGSM. And from our research, we get some data in VG1, redocking validation, research again the 4i5i receptor with the grid box size is at 40, 40, 40, and coordinates X, Y, and Z in this parameter against ligand for the crystallography, resulting in a value of RMSD 0.374 angstrom. For this RMSD result, the docking validation is valid because the RMSD value less than 2. This is table 1. From the docking result we get we can compare the comparison compound and test ligand or the sign ligand. Just from the free energy binding, we will comparison the sign ligand we get minus 8.36, and then the comparison we get minus 6.29. And this is the constant inhibition, and we have from the free energy binding significant with the constant inhibition. From the free energy binding, we concluding that the test ligand more stable than comparison combined. This is the overlay of the native ligand from docking structure result rates and crystallography result in a blue color. This is another visualization from the docking result. The I is the comparison compound, and then B is the design compound. In the comparison compound, we get three hydrogen bond interaction in IL, KLN, and ASN, and about 1, 2, 3, 4, 5, 6, 7, 8 hydrophobic interaction. But in the sign of test ligand, we get 2 hydrogen bond interaction in this ASP and VAL, and we get about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, about 13 hydrophobic bonding. And from this result, I think the sign compound more stable than the comparison stable. And then we get the pharmacokinetic prediction. We just parameter about CaCO2, HIE, and H, and the Lipinski rule of 5 we get 2. If we comparison the comparison compound and test ligand, I think almost similar the comparison and test ligand. I think the fulfill the pharmacokinetics and Lipinski rule of 5. And the conclusion of the research is, based on the results, it can be concluded that the compound has a free binding value is minus 8.36 kilocalorie per mole, better than the 1-benzoyl 3-methyl urea minus 6.29 kilocal per mole. And from the pharmacokinetic and from the pharmacokinetically and the toxicity of the initial compound is better than the test ligand. Both can be used as oral drugs because they are in accordance with Lipinski Rule 5, but with certain restriction because the similar in LD50. And with thanks to the penelitian pasca Dr. Grant from UI and from the Ministry of Education, Culture, Research, and Technology of Indonesia. Thanks to Stikes Bakti Tuna Susada and Universitas Perjuangan Tasikmalaya for the provision of the facilities to complete our research. And thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.